Hello, Honors Algebra 2 students. I hope you had a wonderful, relaxing weekend. I hope everybody in your family is continuing to stay safe and healthy as well as you. And I just hope that you're following all the restrictions and orders and staying safe. So today, Tuesday, March 24th, is a wrap up of the graphing that we are working on for section 8.3 of rational functions. I wanted to kind of just take you through the Google Classroom so that you can kind of get an idea of what it looks like again. So I have my screen up to your Google Classroom page, and at the top you have the material for today, Tuesday, March 24th. I'm going to start posting these as daily groups of material, or it might be as like a section of material. It just depends on what the day looks like or what the section looks like. But the first thing you see here is the agenda for the next couple of days. So I kind of grouped the next few days together and just pulling that up so you get an idea of what that looks like. And of course it says it's not found, so I'm going to have to check that out in a minute to see what's going on there. But the agenda will be posted since it's not there currently. And then there's a survey underneath that, and that survey is just a little remote learning survey as to how everything has been going for you with the FID days. And just ask a couple of questions in there. That's not graded. It's just an informational survey for me to kind of use as I make my lesson plans for next week. The graphing analysis summary is underneath, and we're going to go through that as notes today, just to kind of summarize all the steps and the parts of the graphs that we've been working on. And then the fourth part down right there is the section 8.3 practice A worksheet, and that's going to be the homework for today. And then, of course, the solutions, as always, are right underneath for you to check your answers. So what I would like you to do is find the worksheet from last week, and that worksheet was the section 8.3 worksheet day 2. It's underneath the chapter 8 material. A lot of you have turned this in to me already. Some of you have not, and you still need to make sure you do get that into me. But we are going to go over numbers 4 and 5 from this worksheet. The graphs of the worksheet for 4, 5, and 6 were definitely more interesting than the other graphs, so I thought we would take a peek at some of those problems just to kind of review and summarize the graphing. If you already have this done and you have it posted, you can pull out the picture that you have posted, or if you have it as something that's printed, you can pull out that worksheet that you have printed. However you have it, if you could find that worksheet, we're going to go over that right now. And if you need to pause the video so that you can find that worksheet, feel free to pause the video. So as I said, we are going to look at number 4. And number 4 is f of x equals x over 1 minus x squared. So the key thing when you're working through these problems is to kind of think about where everything is coming from. I need to see a little bit of work so that I understand that you understand where you're getting the information from, so that you know the parts of graphing and I can physically see that you understand those parts of the function and how they affect the graph. So for the x-intercept, we usually take the top of the fraction and set it equal to 0. Well, in this case, it's x equals 0. Yes, I need to see that little step so that I understand where that number that you're writing, the ordered pair, is coming from. So the ordered pair would be 0, 0. The y-intercept is found by taking the function and replacing 0 in for all of the x values. Again, that little step there, I need to see that so I can understand where you're getting the ordered pair 0, 0 from. Vertical asymptotes. Well, the vertical asymptotes, we usually set the denominator equal to 0. So if I do that, I'm going to show my work up above since there's space up above. I can solve this equation for x squared by taking the 1 to the other side. We would divide, and then I'd take the square root. When you take the square root of 1, your answer is 1, but it's also negative 1. So that's why the denominator has the vertical asymptotes, there are 2 of them, because we have a value at 1, and we also have a value at x equals negative 1. The last part is the horizontal asymptotes, and that's when we look at the powers of the leading coefficient. And in this case, the power on the top is less than the power on the bottom. And because of that, we get y equals 0. So that would have been the second kind of property that we talked about with asymptotes. Finally, we have domain and range. You can choose to complete the domain now, or you can wait till after you have the graph done. But the domain directly corresponds with your vertical asymptotes. So if I'm looking at my vertical asymptotes, the graph is going to go from -1 to the first vertical asymptote on the left, which is, negative infinity to -1, the first vertical asymptote on the left. And then it's going to be in between the two vertical asymptotes, -1 to 1. And then it's going to go from the asymptote on the right all the way up to infinity. If you can't do that without graphing, that's okay. But we will get to a point where we should be able to know the domain and the vertical asymptotes correspond directly together. So that would be the information and a little bit of work that I need to see to correspond with the graph and how we're finding that information on the graph. The last part is to actually graph it, and to do that we're going to make a t-chart. We're going to pick a couple of numbers from that t-chart. But I'm going to actually plot a couple of points on here. So we have 0, 0. And then we've got an asymptote at 1 and -1. And then we have the horizontal one at 0. Notice how the horizontal asymptote goes through the x and the y-intercept. And that happens every once in a while when you have those two intercepts, or the two asymptotes. Something's going to go on in the middle of those, and sometimes it's going to cross over that horizontal asymptote, and that's okay. It will never cross a vertical asymptote, but every once in a while it'll cross through that horizontal asymptote. So good points to choose. Remember, we're trying to get numbers to the left, in the middle, and to the right of those asymptotes. So if we pick -3 and -2, that would be to the left. In the middle, if I have asymptotes at -1 and 1, we're going to have to choose numbers that are fractions. So -1/2, +1/2. And then we might as well choose a +2 and a +3. So you're plugging those into the original function, and that original function has an x on the top, and then 1 minus x squared on the bottom. So plugging in the -3, we get 3/8. Plugging in the -2 is 2/3. Plugging in a -1/2 is -2/3. And then we're plugging in a +1/2, which is a +2/3. And then finally plugging in a +2 gives us a negative and then we have negative. So if we plot our points, I can see that they are increasing. And I know we don't have a lot of points to go on, but those will increase and skim along your asymptotes. We need to use those asymptotes to help us graph. So understand that after you have your points plotted, your graph is supposed to approach the asymptotes. There, that looks a little better. And then in the middle, at a -1/2, we have a -2/3. A +1/2 is a +2/3. Again, that's not a lot to go on, but I know that my intercept has to connect to the next point and approach the asymptote, connect to the next point and approach the asymptote. Make sure you extend those. Don't just stop a little bit. Extend those on so we see what the graph is doing. And then the last two values, we have a -2/3 and a -3/8. So this should be our graph for number 4. So finally, finding the range, now that we have the graph drawn, if we want to get the range, look at the graph as a whole. So yes, the left side is going up to infinity, the right side is going down to infinity, but that middle part of the graph, that's going all the way down to negative infinity, passing through 0 and going all the way up to positive infinity. So that means the domain would be negative infinity to positive infinity. So I want to talk a little bit about number 5. We're going to just talk about the vertical asymptote in number 5. Remember, to find a vertical asymptote, we have to take the denominator and set it equal to 0. Well, if I take this denominator and set it equal to 0, it's quadratic, just like the previous one, but this quadratic's in ax squared plus bx plus c form. And the only way to solve for x in a quadratic is my favorite thing to do, factor. So we've got a negative 6. We're trying to make a negative 1. It's a negative 3 and a 2. This is just regular old factoring, basic factoring. X minus 3, x plus 2. Remember, you're supposed to set the denominator equal to 0 to find the vertical asymptote. So if you now solve for both of them, you end up with x equals a negative 2 and x equals a positive 3. There are two vertical asymptotes again. We found them by factoring. I need to see how you're finding those asymptotes. A little bit of work up here to show me where they're coming from. They don't magically appear. They have to come from factoring. The horizontal one, top is less than the bottom, so the degree of the numerator is less than the degree of the denominator. That's going to be y equals 0 again. And then looking at number 6, again, I wanted to go through a couple of these so you can kind of see what was happening. So number 6, we have x-intercepts, so taking the numerator, setting it equal to 0, showing a little bit of work. 0 would be equal to 6x squared, so if I divide by 6, x squared is equal to 0. That really just means 0, 0. For the y-intercept, again, taking the equation, changing x to 0. So I get a 0 on the top and a 1 on the bottom, 0, 0. Vertical asymptote, I need to take that denominator, set it equal to 0. Well, if you solve, you end up with x squared equals negative 1, and when you take the square root of negative 1, you get an imaginary number. Well, we don't graph imaginary asymptotes. Lucky you. So that means that there isn't a vertical asymptote. And then the last thing to look at is the degree of the top versus the bottom. And it's the same. So the degree of the numerator equals the degree of the denominator. When that happens, your asymptote are the coefficients in front. So there's a 6 on the top and a 1 on the bottom. So that's going to be at y equals 6. So if there's not a vertical asymptote, that means the domain has no restrictions. And it's negative infinity to positive infinity. We can't do the range until after we graph it. So we're going to get some points here. My x values pretty much can be anything because we don't have any restrictions and there are no asymptotes. So we have a point that we know for sure at 0, 0. And we have an asymptote up at 6 across the y. So there's my asymptote. So I want to pick a couple of numbers that are to the left and to the right of that point. And maybe spread them apart a little bit. So maybe a negative 4, a negative 2, a 1, a positive 2, a positive 4. And this one gets a little messier because you have a 6 times the x squared on the top, x squared plus 1 on the bottom. So if you want to make them into decimals, that's fine. This one's approximately 5.6. When you plug in a negative 2, it's about 4.8. When you plug a 1 in, a negative 1, you get a 3. A positive 1, you get a 3. Then on the other side, you get the same numbers. When that happens, it's called the graph being symmetrical. So now that I have those numbers, we're going to see if we can get a graph here. That first one's going to be pretty close to the asymptote. And then I have the same points on the other side of the graph. So remember, when you connect these, they skim along the asymptote. It should be curved. These aren't absolute value graphs. And it's going to go down to that bottom part. So when we do this range, the range starts at 0. That's the x-intercept. Well, it's touching 0, so it gets to be a 0 and a bracket around it. And then it goes up to 6, and it doesn't go beyond that, so it gets a parenthesis. That graph was a little different than the other graphs that we looked at. So hopefully seeing those couple of problems completed helps you kind of understand where the information is coming from, especially when you look at the answer key and we're not in class and you're thinking, how are those answers kind of being created? And you got to see 2 of the graphs as well. So if you want to pause the video for now, feel free to pause it. We are going to complete the graphing analysis summary worksheet. So that worksheet, again, is posted to Google Classroom. So see if you can find it. We are going to just kind of do a quick review of where all that information comes from a graph. If you were looking at the agenda, kind of notice that the agenda says there's going to be a test next Wednesday. So the goal is to kind of prepare for that. So this kind of review will hopefully help for that. And then also on Thursday, there will be a review that we're going to do for sections 8.1 through 8.3, which was mostly graphing, but remember that 8.1 had that inverse variation and joint variation. I'll have a Zoom session on Thursday, and the information is provided in the agenda for that. All right, so finding the x-intercepts. Remember this function, y equals p of x over q of x. That's the form of a rational function. So the x-intercepts, we take the numerator, set it equal to 0. You can even pause the video, see if you can answer all the questions, and then just kind of skim through it to make sure that you have the correct information written down. So if we take the p of x and set it equal to 0, that really means we're taking the numerator equal to 0 and solving for x. Your ordered pair should be x comma 0. Finding the y-intercepts, that's when we set y equal to 0. And of course solve for y. Not y, I'm sorry. Let's go back. We're setting x equal to 0 and solving for y. Your ordered pair should be 0 comma y. Vertical asymptotes, that's when we use the denominator, q of x, and set it equal to 0. Again, solve for x. You may have one one vertical asymptote. You might have 2, but they should be in x equals form. X equals something else. And then the last one are the horizontal asymptotes, and this is where those 3 conditions. So we're comparing the degree of the numerator. If it's equal to the degree of the denominator, then we have an asymptote at a over c, which are the coefficients of the top divided by the coefficient of the bottom. So our second option, if the degree of the numerator is less than the degree of the denominator, then it's at y equals 0. Our third option, if the degree of the numerator is bigger than the degree of the denominator, then you have no horizontal asymptote. So those are the 3 different cases for asymptotes, and it's one of those 3, depending upon what's going on with your powers on the top and the bottom. That's the degree. So the last 2 parts are getting domain and range. As we said in those other problems, the domain corresponds directly with the vertical asymptote. And it's going to be in terms of x, since the vertical asymptotes are in terms of x. So it would be from negative infinity to your vertical asymptote, and then the vertical asymptote to positive infinity. If there were 2 vertical asymptotes, then those 2 vertical asymptotes also get written in the middle. You can always rely on the graph as well. The range, we have to use the y values of the graph. and you really do need to look at the graph to find the range. So that is a little summary of the graphing that we've done. If you have questions, please let me know. You feel free to email me. I can answer those for you via email. Or you can join the Zoom session on Thursday, and I will be able to answer any questions that you have on graphing. Hope you have a great day.